Alright, so the last time we were working, we talked about a variety of things, but now what I'd like to do is to show you something about using lights in a control system. So when you use lights as part of your control system, so let's say you have a light curtain, which would be a phototransistor and a light, okay, or you're using a light and a photoresistor to do some things. What I really like you to do then is to have a way to be sure that your system's working. Alright, so as you do that, you need to be aware that when you're using lights in the system, the first thing you should do is start your program and turn your lights on. So if we imagine in this application that we were using a lighting system, say to determine when to stop something or when there was a part or those kinds of things, the first thing we should do is turn the light on if we're using it, okay? And then put a small delay in below that. Alright, now let's just say that when you were using this to increment a counter, that every time a part came past a phototransistor that was mounted here, you wanted to increment a variable. Alright, so you could do that with something like this. Okay, I said we were going to use a phototransistor, so that would be a digital input, so I selected a digital branch. Alright, and I'm going to change the sensor to phototransistor. Okay, and then when it does that, I want to increment a variable. And after it counts, I just want it to return to the top. Alright. Okay, and so in our scenario, let's imagine that what I have is the phototransistor and a light placed directly across from each other. So every time that sensor that you put a part there, it's going to count, right? So when you do that, okay, you might have something like this, right? So I1's normally going to be a 1, not a 0, so we need to swap these branches. Okay, and then so you notice my program here, and this is just an imaginary scenario for you guys, okay? But the point I want you to see is that when you're using lights for a control system, you turn the lights on first, and you're sure that they get up and running before you start running your process. Just like in industry, you would never start running live product until you were sure your control system was up and operating well. But I never want to come back and include this little 1-second delay in here, and there's no reason to be turning those control lights on and off. Okay, so lights as part of a control system, you just turn them on and leave them on. Alright, is the idea there. And what's the reason for this? Is because if you're using them for the control system and you don't do this first, the light, your program, quite honestly, could move through the section where you turn the lights on and get to this decision block before physically the light gets on and illuminated. Because remember that basically the program, if this 1 second timer weren't here, is moving through at the speed of an electron. However, it's physically going to take a second for the filament in that little LED to light up. Alright, so I want you to understand kind of the difference in what the idea is here, and also that when you're using light for a control system, turn them on first, leave them on, use a little delay. Alright, I hope this helps.